Welcome back. In this tutorial, I'll be introducing the concept of existential import and talking about the difference between Aristotle's approach to categorical propositions and a more modern approach to the categorical propositions that takes into account the development of a more modern scientific method. So let's start with Aristotle. Here we have the traditional square of opposition, and just to review, each corner represents represents two different characteristics. The quantity, either universal or particular, and the quality, either affirmative or negative. So, for instance, all S is P is a universal affirmative because it says every member of S must belong inside of P. In order to illustrate that, we construct a Venn diagram and shade the portion of the S circle that's outside of P, which in effect forces all the S's there are inside the P circle. So that's shading means empty. That's what we mean by that, right? If we look at universal negative, we see that the shading is in the region of S overlapping P because that region is empty, which means there are no S's that are also P, which is exactly what we mean when we make the claim no S is P. With particulars, we're talking not about every member of S, but only about at least one. That's what sum means in logic. At least one S is a P. And for that reason, we put an X to indicate that at least one in the overlapping region between S and P. So what this X shows is that there's at least one S that's also a P. Similarly, in the particular negative proposition, some S is not P, we put the X in the region of S outside of P to indicate that there's at least one S that is not a P. So notice here again, the proposition is about some member of S, and in this case, some means at least one, and not about every S. So that gives you the idea that these four types are really derived from the quantity and the quality of propositions, which can either be universal or particular in quantity, affirmative or negative in quality. The quantity, again, has to do with how much of S we are asserting something about. All of it, as in universals, or just at least one, as in particular. Affirmative and negative refers to whether what we're asserting is an inclusion or exclusion relation. So for affirmative, the portion of S we're talking about is included in P, and for negative, it's excluded. One last detail here is that each of these propositions is nicknamed by a vowel. So for instance, I is associated with particular affirmative, O particular negative, and across the top we have the A proposition, which is universal affirmative, and the E proposition, universal negative. So that's basically a review of the square of opposition. Now let's talk about how Aristotle approaches universals. For Aristotle's logic, which he uses the word logic in a broader sense than we might be familiar with today, to mean the whole process of gaining knowledge through scientific inquiry, right? So in Aristotle's view of science, you couldn't do science about things that don't exist. So for instance, we could do science about goats or cows or tables because those things exist, and because they exist, we can get examples of them and we can draw conclusions based on those examples and the species and genus to which those items belong, right? But you cannot do science on something like unicorn for the simple reason that anything you claim about a unicorn might or might not be true, for the simple reason that there are no unicorns for us to identify and collect, as it were, and then examine to see whether assertions are true or false. So, to make a long story short, what that means is that for Aristotle, logic in the broad sense And logic in the narrow sense has to deal only with things that actually exist. So for instance, when we say all S is P, for Aristotle, what that involves is claiming not only that every member of S must be a member of P, but also the additional claim that there have to be S's and P's, and in this case we mean at least one. In other words, the things we're talking about have to exist. Similarly, for no S is P, the claim is not just that no S is P. The claim also implies that there have to be P's and S's in order for us to make the claim no S is P. So how do we represent that on this diagram? Well, we use the convention that we used with particulars, meaning we can put an X to indicate the existence of the categories involved in the universal affirmatives and negatives. So for instance, for universal affirmative, what we're going to do is put the X right here in the region of S overlapping P, and what this X does is it indicates both that there's at least one S and also that there's at least one P. Why is that? Because this is the region of S overlapping P, and because that region overlaps with P, then anything that's in there has to be both an S and a P. In other words, it only takes one existing thing in this region to ensure that there is at least one S and at least one P, because anything that is in this region is both S and P. The story is a little different in the negative, in the universal negative, because we have to show that there's at least one S, but we also have to show that there's at least one P. Again, because for Aristotle, it made no sense at all to make logical or scientific claims about things that don't exist. So this would be the diagram for universals on what we call the Aristotelian interpretation. So if we add the Aristotelian interpretation to our to the slide here, this is the complete Aristotelian interpretation. Now, what does that mean? First of all, it only has to do with universals. Particulars always imply existence, because if you're talking about some S is P, for instance, some cow is a Jersey, then that is a reference to an existing thing. There's at least one cow. That at least one cannot not exist. So the interpretation does not apply to particulars. Particulars always include existence. Now, what's the alternative? Okay, so to see why the alternative is important, you have to see how science developed since Aristotle. For Aristotle, science was fundamentally an observational or an observation-based enterprise, which means to do science we have to observe the entities about which we want to draw conclusions. Now, if you think about that, the logic means that there's no way that we can do science about things that don't exist, because we can't observe them and we can't collect them and study their properties, right? But think about the way science evolved after, especially quickly after the late medieval period with people like Roger Bacon. During that period, science took a turn in the direction of what we call the hypothetico-deductive method. This is a method of proposing a hypothesis and then coming up with ways to test that hypothesis. Now, if you think about this for a minute, you'll realize that the hypothesis also often has to talk about things that we're not sure about in terms of existence, right? So let me give you a really concrete example of this. When I was an undergrad, nobody had any empirical evidence that there were black holes in the universe. All the evidence we had was math. I mean, basically, the math predicted that there ought to be these entities that were so massive that no light or other radiation escaped from them, which meant that they would be black, meaning unobservable. So in other words, these were hypothetical entities, but from these hypothetical entities, we could draw inferences and conclusions that would help us look for evidence of them. So let me give you an example. Back when I was an undergrad, it made perfect sense to say things like all black holes have infinite density. But the problem with saying a sentence like that on the Aristotelian interpretation is it's not allowed unless you already know that black holes exist. If you don't, it's an illegitimate claim, just like unicorns have one big horn in the middle of their head. That's a claim about unicorns that's based on a common understanding or a definition. But think about trying to verify that. There's no way to go get a unicorn to establish definitively that that is a characteristic associated with the unicorn. So there was a philosopher named George Boole who noticed this problem. And he said, okay, look, we can fix the Aristotelian problem just by refusing to take a side about whether universals require existence or not. In other words, it could make perfect sense to say all black holes have infinite density if we don't know that there are black holes, because we can just decide not to decide about whether they exist. In other words, when we utter a claim like all black holes have infinite density, what we're really saying is if there is any such thing as a black hole out there somewhere, then it's going to be a thing with infinite density. If you think about the logical form of that sentence, that is exactly what we mean when we say all S is P, as long as we don't assume that there have to be S's and P's. So Boole proposed that we interpret Aristotelian universals, that is the A's and E's, right? We just interpret them without any implication of existence at all. So this is the diagram that matches that interpretation. Notice, it's the diagram we kind of started with intuitively before we started talking about Aristotle. But if you think about this diagram for the universal affirmative, the interesting thing about it is, sorry about that. The interesting thing about it is it tells you that all S's have to be P's, but without telling you whether there are any S's or P's. So look at the diagram. There's no X in there, which means we don't have definitive indication that there is an S that's also a P, but we also don't have any definitive indication that there's not. In other words, we just don't take sides about whether the proposition all S is P tells us that S's exist or P's exist. Same with universal negative. There are no X's in this universal diagram, and because of that, it's as it were, open question whether there are S's and whether there are P's. What the diagram does tell us, though, is that if there are any S's or P's, then they will not be P's or S's. In other words, look at S. It doesn't tell us there are any S's, but if there are any S's, one thing we know about them is they will not be P's. Same thing with the P. If there are any P's, then we can tell by the diagram, because the diagram tells us what region is empty, that those P's will not be S's. Okay, so just to summarize this, the Boolean interpretation also applies only to universals, because even on the Boolean interpretation, some S is P is going to imply that there's at least one S that is a P. So think about it in a practical sort of way, right? What's the difference between saying some cow is a Jersey, right, and some unicorn is a pet? Well, the difference is with some cow is a Jersey, we know for sure that there's at least one cow, so that proposition makes sense, right? Some unicorn is a pet is sort of like a fictional thing. That's something that could happen in a story or, fiction, but it's not something that can happen in reality, as it were, not in the literal sense, right? Because there are no unicorns. So anytime we use a positive statement, anytime we use a negative or an affirmative particular statement, we're saying something positive about existence. In other words, we're assuming existence. So the Boolean interpretation, Aristotelian interpretation distinction does not apply to particulars. However, it does apply to universals, and the Aristotelian interpretation assumes that universals must imply existence because that was Aristotle's philosophy of science. We can only do science about things that we know for sure exist. A more modern notion of science involving hypotheses suggests that we don't have to know something exists in order to say something intelligent about it, based, for instance, on mathematical models or definitions or whatever, and that's the Boolean interpretation. It just does not take a position on whether the categories in a universal proposition actually exist.